Welcome to another episode of Energy Bytes. I'm Bobby Nealon. I've got the rad dad, John Calfan, here with us.
How's it going?
It's going great.
Been a few weeks. We've been
it has
crazy busy. You've been moving
a full week of internet and power.
A couple tornado and a hurricane and all kinds of fun stuff.
All kinds of good stuff. And then we've got Stephen Pace with us today from Snowflake. You're a principal sales engineer, correct?
Correct.
And based out of here in Houston. So really glad you could join us.
Thanks. Happy to be here.
Yeah.
Well timed since as of today, basically, it's CrowdStrike has, I guess they're slowly rolling out a fix, or I don't know.
Well, they didn't slowly roll it out.
It's true.
They shoved it out.
They're not pushing patches anymore, it sounds like. But
yeah. If you search for, I don't know if you can edit in graphics as you're doing this, but if you go to the Azure status page right now, they have a big long, like normally it's like, different colors or whatever. They have a big long thing of, hey, this is what's happening and that. So it's rough. It's one area that, Snowflake is multi-cloud. We started in AWS, but then we went to Azure, and it's our fastest growing platform, and we support Google as well. But what's kind of funny in this case is we can help isolate customers from these type of problems. Is because if you wonder, like, well, if I can't get machines, how is it that Snowflake is running? It's because we ahead of time are spinning up hundreds of thousands, millions of machines around the world. And so when we keep, we have them, and if we detect there's a problem getting new machines, like if they would start, they would blow up, we don't give them back.
Okay.
We just keep them, and then, we stop giving them back, and then customers are still running. They could have problems in other things that they have because they maybe try to provision something outside of Snowflake, but for the stuff we're running, a lot of times we'll just keep running. And so it's interesting. It reminds people about the concentration of tech. Like we have customers like Caterpillar that are multi-cloud that practice failover between AWS and Azure and do that. That's a hard thing to do, but if you're somebody of that size, then it's worth it. But it's we all saw this, and it's not just Azure that has this, but like, remember there was a story a couple of years ago where like people's Roombas stopped working. And it's because there was an AWS region that went away, and people were like, why is my Roomba even using the cloud?
It's usually US East 1, isn't it? Like,
so that's
always
a big
the most common ones that everyone uses.
So other ones have had that. And, the last big Azure outage, they had an Active Directory outage, which then you couldn't log in. So then, nobody could use Azure. So then it gets people thinking about like their failover strategy.
Yeah, big time.
So, because a lot of times, like when Snowflake, if it just runs for a year and you never have one outage, you're like, well, I'll put that off. But then if you have something that impacts, then you're like, okay, I need to think about it.
Yeah, because I think at least last night, we're on Snowflake at work, and I haven't dug in enough to know if it was on the Snowflake side, but we were starting to get a bad gateway, errors or for connectivity. A lot of jobs are failing, but we have a lot of stuff tied through Azure as well. So it might have been tied to that, but because ours runs on US Central, which I think was the one that.
Yeah, that was the one where we had the most.
The main ones.
Yeah, like everything was down, was like just red for Azure Central. But
I read it's the biggest outage in IT history as of today.
Oh, I believe it. Yeah.
And then I saw
like banks. And I think their TV stations couldn't get up. Airlines,
there was a lot.
And across the world too. I was like, I saw a picture from Amsterdam this morning. Like,
Berlin airport closed, and I had a friend.
Could you imagine being at the airport and just seeing all the screens, blue screens
of death, like,
just
across,
be like, well,
this is encouraging. Hopefully my plane's not running Microsoft.
Right.
I had a friend from high school that's on a big trip, and their flight got canceled. It's like, why? It's like, well, the whole airport's closed.
Yeah.
And so it was having to navigate that. How could the whole airport be closed? But it's
even just like, I saw like time-lapse GIF of the flights yesterday, and it was like, it reminded me exactly of what 9/11 looked like when it literally just shut down all of air traffic. And it was just like, oh man, that's a hell of a mess up there.
Yeah. Well, awesome. So, diving into, let's talk about what you're working on now, or what, really I want to dive in about Snowflake, because we hadn't really had anyone on to talk, deep about Snowflake. But there's, we're using it. I know there's definitely more than a handful of people in oil and gas using it, and across the energy space as well. Again, we're not exclusive to oil and gas, but we do a lot of it. But just, if you want to talk about, what you do with them and like maybe some projects you're working on, but then also, you guys just had Snowflake Summit, and maybe we can talk about some of the new additions, and maybe, I don't want to jump the gun. Let's start, like, if people don't know what Snowflake is, like, can you, start at the highest level? Like, what is Snowflake? And
why do I need another database?
Yeah, so there's a lot of that, and that's really kind of where I came from too. Stepping back a little bit, I can't, my first job was at Shell and wrote some software, part of a team that was supported like data warehouse automation. And then we ended up using some VCs and we bought out Shell and we became our own independent company. And so I was in the data warehousing space for many, many years. And so, I was very much in that camp of, look, we have some good databases. Why do we need something else? And I think the thing that woke me up to maybe why you would need something different is I saw the evolution of Netezza. Okay. So we supported platforms like Teradata, and here's this upstart of like, why do I need this Netezza box? And I saw how they sold it, which was, hey, you got a slow Oracle Mart. We're going to roll this box in. We're going to take all the data and we're going to run your query. It's going to be faster. And so we're, solving a problem that people had. And, that caused a lot of consternation for Teradata. Then, we're going to change our strategy. We're going to have a small box. But that at least woke me up to where I can see why you would need something. And I think this is an area where Steve Jobs is really good is there's periods and inflection of technology. And I kind of consider myself a technology person that things are impossible until they aren't. Right? Yeah. And so he'll see something like he'll go to Xerox PARC and see a mouse and go, okay, well, the world's changed. We're going to do something different. Or he'll see a flat screen and say, oh, this is going to be our phones and everybody's going to do that. And, Microsoft, Steve Ballmer will make fun of them and say, oh, we've been in phones forever. They're not there. There's all these problems you're going to have to work through. But he'll go, yep, but we're going to work through them. And then everybody's going to have an iPhone.
Look up Windows Phone.
So, and this is the thing. So this is kind of the world I was coming at it from. And I don't know if you recall back in the Hadoop, maybe this is a little bit of the management by airline magazine kind of thing where, people are like, data warehousing is dead. We're going to just, there's this new thing, it's Hadoop, and you need to have, and it's because, why do we need it? Well, the 3 Vs or 4 Vs, depending on how you do it. Yeah. We have the volume and the variety and the velocity of data is just such that regular databases can't hold it. We're going to have this other thing, which I just thought was so funny because it drove companies like Teradata crazy. Because big data is like the stupidest term there could be, because they're like, we've got multi-petabyte data warehouses, and you're saying this big data thing is not, and so it drove them mad. But it kind of was, I think, good from a marketing thing of like saying it's different, but also making the existing companies feel like, are we legacy now and all this stuff. So that world came up, and one of our founders, and this, so I kind of came at. I knew two people. There was a guy in the Woodlands. His name is Kent Graziano. Okay. He was sort of our first evangelist for this. And I was helping out with Dama here in town, and we would have speakers. And Kent came in, and I saw a very early on demo of this, and so I kind of it was on my radar. And then I read a thing from one of our founders. He's a French guy named Benoit. And somebody asked him about Hadoop, and he just, everybody gives these nice things. And I think a lot of times in the media, they we're going to get somebody with a controversial thing. And I just happened to see it because his was he basically said Hadoop is stupid. We can solve this another way. But if you're going to move to the cloud, you need a fundamentally different architecture. And Snowflake really is a completely different architecture. Mm-hmm. And so he thought through, if you're moving to the cloud, what would you need? And then it's, we sort of pioneered the separation of storage and compute and these things, and he just worked through that. And so when I saw that, I go, okay, I'm aligned to that guy. Yeah. So it got on my radar. It went out of stealth, and then it was the right time. It's like, okay, I'm going to move over. And I was employee 1,100 or so. So still we were kind of sizable. At that point, we're saying we're a cloud data warehouse. We were always meant to be a platform, but you can't just sell something that is nobody knows. So you have to say, we're going to do this.
We're really good at this thing. Yeah.
Yes, and we could crush Redshift or Synapse and all these things that would just let customers play with it. And even to today, you can go on the Snowflake website, you can go to signup.snowflake.com, you can click, you can get a trial, and you can just play with it.
The simplicity is probably the most beautiful part of it.
No, absolutely. I remember the first time I stood one up, it was because Bobby was like, just go stand one up. Yeah. It's literally a few clicks and you've got one stood up. And I was
it just worked.
Yeah. You don't have to have Google, because BigQuery is a fine, warehouse in a similar vein, but you have to have a Google Cloud account. And then there's all this, those.
I've got to go set up all the APIs and the service agents and make sure all the permissions are correct.
You got to secure it.
Yeah, and those consoles.
Tie it into my SSO and all this. And it's pretty soon it's well, I just want to go do this.
Right. I just need a database to hold my data. I don't want to be an IT manager.
Yeah. So, I mean, now if you look out, so if I was 1,100, there's like more than 7,000 people now. So it's just growing and growing.
Yeah.
And so I was brought in to help. So I'm in pre-sales, meaning there's usually the way it works in techs for pretty much all the tech is that there's an account exec, and then there's a technical resource with them that understands the platform, and you're sort of a pair, and you go in there and you can talk about, hey, how Snowflake works, how does it compare to what you have, how does it integrate with all your other stuff. And so my initial customers were brought in for Exxon and some others. And I guess just proximity of being in Houston, you have more energy companies. Not that they're only energy, like we have Taylor Brands, like Joseph Banks and those kind of companies. What's cool is as you drive down I-10, almost every big building now with the logo is now a Snowflake customer. So yes, if you look at like from Katy on, like you see ConocoPhillips and Technip FMC, I think they just changed the logo on their building. But if you look down the Beltway, as you pass the Beltway, you see BMC or NOV off of there.
Marathon,
Cemex, Marathon is another one.
And they're right by us.
Yes. So, I mean, it's kind of cool to see it evolve, how it's evolved, but it's in every case, it's like, hey, we've got this problem. A lot of cases in the early times was moving from Hadoop, or if something very expensive like a HANA or something. And it's like, how can Snowflake help in that? Well, it's like, well, okay, kind of, I think Marathon was sort of making the joke. They said, you guys are $23 a compressed terabyte. HANA is $1 million a terabyte. And that's not, I know it's not an unfair, one's in memory and everything, but they're basically like, it's very expensive and you guys are very cheap. So
yeah, I mean, the storage is just a pass through, right? I mean, like it's roughly what a S3 bucket costs at the hot tier, right? Like, but then the fact, I think it's the compression side of it is the huge part.
Yeah. And compression is very good as well. So
I don't know if we're going to dive into that at all, but I mean, like,
yeah. So there was a kind of a funny thing that it kind of hit the stock one quarter because we improved our compression algorithm 30%. So one day you go to sleep, you come back the next day, and now suddenly all storage moving forward is 30% less than even what it was. So I think our compression rates, and it's different for every kind of data, but if you load a terabyte of data, it's not unusual that it'd be like 200 gigs after you load it.
Wow. Yeah.
So
it's about 6 to 10x.
Yeah. And we get a good ratio. So our commit to AWS. This is public information. I think it's something like $2.5 billion, a multi-year contract. So we get a pretty good rate. And then we try to pass that on to customers. And $23 is the starting rate.
Yeah.
So if you're a bigger Snowflake customer, and it's right on our website. This is another thing I like. We're very open. You can go to snowflake.com/pricing. You can see the price list and it says $23. But as you start to increase, I think it goes down to like $13 or something like that, whatever. So we're trying to be competitive for, keeping it out and something else. So, yes, you can keep it yourself. You can manage it yourself. We support iceberg tables, for instance, a very popular open table format.
Yep.
If you want to manage it, if you want to take on that extra homework, you certainly can, but you got to beat that price. For big customers, it's hard because it's like there's a lot of management that goes into it. It's not only that it's that cheap, it's that we're managing all the file sizes and
even the file structure and everything too, right? I mean, all the partitioning and that's not trivial. I mean, like I remember going to like an AWS data lake, in a day kind of training. And it was like, you really got to be intentional about how you set this up and like how you partition files and do everything under the hood. And then you have to secure it. I mean, there's so much that goes into it to do it well. And like you're saying, can you beat Snowflake at their game? Like it's not likely.
Yeah, it's hard. I know I'm probably giving too long of answers for a podcast.
No,
but like, just one example of that, because we had a customer that said they wanted to take on that. And if you have a big engineering team, you can do it.
Sure.
But, our micro partitions, the default size is 16 megs. And like, imagine you change a file. Well, now you either going to have a sparse file, like let's say you add one record. You could have a micro partition that's 16 megs and then one that's like one row.
Yeah.
But that now you're joining things that are unequal size. So we're like constantly compressing them. And like if you change a row, we're going to rewrite that micro partition and we're going to end the old one. And then there's time travel and things. So you could keep it around for a day, up to 90 days if you want. But you just don't have to think about it. It just works. It just looks like it's a table. But behind the scenes, we're leveraging the cloud providers to give like resilience for the storage, because we're using S3 or we're using Blob or we're using GCS behind the scenes. And then our compute is commodity compute. But over the years since I've been here, like we've done, the word in Teradata land is like a floor sweep.
Okay.
But basically you have a certain kind of warehouse, a certain machine type. Next day you come in, all the machines are better. And it's because we put all our machines that I'm talking about in these pools.
Yeah.
We send them back to Amazon or in Azure and Google. And then when we start provisioning those machines, they're a different kind of machine.
Interesting.
And they have maybe more SSD or more memory or whatever they are. But you don't, and that's, we have not changed the prices on that. So our prices over time, if you look, we have something called the Snowflake Performance Index. It tells you over time, if you'd run a certain set of workloads and then move forward a year and you run those same workloads, they're going to be faster, they're going to be cheaper.
But even at the same t-shirt size, right? Because that's kind of what y'all do: extra small, medium, large. So you could keep running things on an extra small year over year, and it'll just get better because you're using better hardware.
Yes, because over the time we've changed. Like in my time, 5.5 years, right, we've changed that at least 2 times on AWS, gotten better machines. Now, there are some other machines now. We have Snowpark optimized servers, which have 16x the memory. So if you're training models now, we're doing more and more in AI front. Okay. Because you asked like 3 questions at the beginning, and I haven't even got to the other 2. But
no, fair.
I
think let's just go organically.
Yeah. So sometimes when you're training a model, you need more memory. So we now have Snowpark optimized servers. We charge 1.5x for those, but now you can maybe use a smaller number of them because you don't need more machines to get the memory you need. You can have less, but each machine has more memory. And then now we have, and it's not as visible to customers, not because they're not in those types of pools where you see t-shirt sizes, but we have something called Snowpark Container Services, which is essentially containers, and those containers can be GPUs. So we now have GPUs in those pools. Some of the machine learning models and things work better with GPUs, so we now have that as an option as well.
If you can find them.
Yeah. Well, we have them because we've paid NVIDIA a lot of money, and we also pay the cloud providers to keep them, and then they're in our pool so that when you need them, you don't have to wait 2 weeks. I have had some customers who said, "Hey, I tried to get a GPU and it took me 3 hours," or one customer said more than a day.
Wow!
But in certain regions,
you guys keep that warm pool. Essentially,
yes, and so there are some other things coming. I don't know what things I could say, but
sure.
So we have them in different regions. At some regions they're harder. So, but you'll be able to leverage some if you approve, where we can help minimize those shortages. So there's some things we can do.
I hope Azure takes notes on that, because it took me a week of emailing back and forth with IT just to get my allocation for one GPU server a couple weeks ago.
Yeah.
So I think there's one more, you hit on a little bit, but I want to go a little bit deeper, almost like I would say Snowflake fundamental, at least what y'all kind of sell there though is, can you talk about kind of the idea of like linear scaling and then kind of the warm pools? So basically that, if I go from an extra small to a small, I basically double my cores and it should run, twice as fast. Correct. In theory,
yeah.
It's and I've tested it. In multiple occasions, it's pretty accurate.
Yes. So this is something that Benoit and Thierry, our founders, came up with very early, is that since we charge per second, and if you can double the compute in half the time, the cost does not change. Yeah. So imagine just
assuming Autosuspend. Yeah.
Yes. So the rough math is for any given job, like let's say a job took 1 hour on an extra small, it would take 30 minutes on a small. So we charge, so at enterprise level is $3 for on-demand price. So imagine the $3, it'd take you 3 hours. So with 1 hour, it would cost you $3.
Yeah.
But with a small, it would take you 30 minutes. So it would be $6 for if it was the whole hour, but because it's half the time, it's still $3.
Yeah.
So now a medium would be 15 minutes, still $3.
Yeah.
Then a large, so you see how you've compressed the time. So suddenly you can do these huge loads from Hadoop and
then time value money. That's
over into
easy,
Snowflake. Yeah. Yes, and you're like, I can compress this time and it costs me no more money. But you're exactly right that at the end of that process, if you flex up to do a big load, you should flex down back to your original size. And that is one thing that's really works very well in Snowflake is we auto suspend. So by default, we're going to turn off if nothing's happening, we're just going to turn off. And some people worry about that because in some worlds, like in a Spark world or something, you're like, well, I'm never going to shut my cluster down because it takes 30 minutes to start up or whatever. And so they just wherever they're speccing the price of things, they're just like, well, just assume it runs 24/7. But the vast majority of Snowflake customers, it's off all the time and you're not getting charged.
It should be. And again, and then the crazy thing is that it's on when you need it, or it scales up when you need it.
It looks like it's on. See, this is the thing that shocks them at first is if you go in there like, well, but if I come in on the weekend and run a query, I don't want to wait 30 minutes. It's like, nope, you're going to come in, you're going to run your query and we're going to provision that cluster to you in under 1 second.
Yeah.
And the reason we can do this is because of those free pools. So we're running these machines, and our job is to make sure we have enough machines. So if a customer comes in and says, I'm going to run my query or do my ingestion or need any warehouse at all, we're going to have them sitting in the pool. So we're managing it. We're essentially, we're a managed service. You asked what Snowflake is. I still have not answered that question, but we're a managed service. So we need to make sure that when you run your query, we're going to provision it and you're going to run it and you won't know it's off. Yeah. But there's a little light on your, if you're using Snowsight, it'll be gray. And when you run the query, all of a sudden you'll see the light turn green. Yep. That means we're billing you. And if you use 1.5 minutes and then you shut down, we're going to charge you for 1.5 minutes. Yep. And so that's different than a lot of services back in the day. Like, I think in Synapse, if you ran one query in an hour, they charge you for the full hour because they're not designed. And I think this is an area where, like for something like Spark, for instance, it really is not designed to run in this serverless managed way because there's so many knobs. There's 500 knobs. And, I think, it's companies that try to do that, in a managed way are going to really struggle. And that's what we've sort of seen ourselves is that people are trying some of the services and we've been doing it for 10 years. It sounds like it's, easy, but it really isn't.
Make it look easy, but yeah.
Yeah. And even this thing with CrowdStrike today, we've, ourselves over the years, as we've gone to more regions and now we support 3 cloud providers, we've done things where we roll something out and we think, oh, there's no way that could hurt anything. We'll roll it out wider and it affects more people. So now you'll see when we roll out a new version of Snowflake, which is every week, we're essentially rolling out smaller regions first. And we have a bunch of canary and test processes. And then if everything looks like it runs, it goes to bigger regions and bigger regions. Eventually you'll see by the end of the week, all the regions will have it. But there's times where we'll sort of internally get notes, like we're going to roll something out. We start to see some kind of indication, maybe something's not right, and we'll just roll it back.
Yeah.
And that's the cool thing is we can upgrade a customer. They could be running 1,000 jobs and we can downgrade them and running 1,000 jobs and it should not affect them at all.
That's wild. Yeah.
So it's designed that way by default. And so it doesn't mean we're perfect, but we're quite stable. And that's what we just want customers is to say it works. And that's why we've got a lot of take up in the energy space, I think, is a lot of times energy companies are running lean and mean. And one of my customers, I'll say, let's say the name, Cord Energy. Now they merger of Oasis and Whiting. Yeah. And when Oasis started, they had 3 people essentially on their team. And, one was like a player coach, one had a lot of knowledge of the internal systems, and one was sort of like a coder. And they were able to move from MapR and SQL Server and move into Snowflake with not a lot of knowledge. They did it themselves.
Yep.
And they were used to SQL Server. So Snowflake presents as a database. And yes, we can run Python and Java and Scala and everything. But if you're used to SQL, you can get stuff to run.
Yep.
And they were very successful and came in on time, on budget, and did that. And then fast forward to now, when the merger happened, I think after they did a little bit of analysis, I think what they told me was it took them 2 days to move all the Whiting data into the same, because you have this period of rationalization or whatever. And after the 2 days, they were able to report both the Oasis and the Whiting stuff together. So it's still very, happy customer, many years of operation, grown. And I just, I love those kind of success stories.
Yeah. Well, I mean, that was our experience too. I came in and I was the data guy, and we pulled a lady over, Michelle, she's on my team now. She was a reservoir tech, but knew SQL, but I was able to pull her over onto my team. But by the time we decided, all right, we're going with Snowflake, and then we went with kind of a traditional modern data stack, Fivetran, DBT, because we're just running so lean. But I mean, again, all of our core data was synced within a weekend and porting over some queries, and within a month, like all the monthly business review metrics and everything were coming out of Snowflake. And it was just the time to implementation and the fact that it works and it's fast. It's just it's just really impressive. So
that's awesome. Yeah, no, we love to hear that.
All right, so I've been holding you up. What is Snowflake?
I should have prepped my elevator speech better.
Yeah.
So when we started, we said, hey, we're cloud data warehouse. And that was just one use case. And that was kind of how we got people to understand it. And then we became the data cloud.
Yeah.
And here's another tie into, let's say the Oasis and Cord case. One of the things that pretty much every energy company does is they get data from IHS Markit, and now it's S&P Global or Inveris or Rystad and these things. And there's also now, like if you have like WellView or something from Peloton, if you need your data, when you ran it on-prem, you could get access to your data because you had an Oracle SQL Server version of WellView. But now in the cloud, how do you get access to that data? Yep. There's a live share. So we started calling ourselves the data cloud, meaning we want to be that one platform where all your data runs. We're going to secure it. We're going to have one governance model, one engine. And that's a breakthrough for somebody like an Oasis, where they can say, I'm getting that data. That's a pipeline I'm having to maintain.
Yeah, the API or whatever else. Yeah.
Yeah, but the best pipeline is the one you don't have to do anything. It's that S&P updates their table, and then you query it 50 milliseconds later, and it's there. Because essentially, technically, what's happening is they're giving you the right to decrypt those blocks from their table. Yeah. It never moves to your account. You're able to query it, join it to your own data, and it just works. So then we became the Snowflake, we're the data cloud. And that's taking on board that idea that, as more and more companies join Snowflake, there's a gravity to data. Yeah. And it doesn't mean you have to share data, but it means there's an opportunity to share data. And you think, oh, maybe it's just energy. But like Exxon, they build these platforms and they have these big electrical distribution systems. And then they're like, hey, we need telemetry out of this box. And then they go, wait a minute, the company that makes that, Powell, is in Houston, and they have Snowflake. So maybe instead of having this API and working all this stuff, we can just say, well, if Powell loads it into a Snowflake and we can get a live share, then so that's a case like, is that energy? It's more like it's part of the data cloud. So we would say we're the data cloud. And we have a CEO that's come from Google. He's the guy that ran their ads business from like 1.5 billion to 100 billion. He's super into AI. And there's sort of like, there's been multiple phases of Snowflake. We started with a CEO. He was sort of the VC that was behind, like that got Benoit to leave Oracle and make Snowflake. His name is Mike Spicer. Okay. Then we had Bob Muglia, who came from Microsoft. He understood databases. He understood how to build teams and scale. Where he is now, I don't. Yeah. I have to.
I think I got that mixed up.
We can Google it, but so Bob Muglia, the right guy for the right time. Then when we went to IPO, we got Frank Slootman. He this guy is a rock star CEO. He's taken multiple companies public. Data Domain, and then ServiceNow, and then Snowflake, and then that was another 5 years, and now we're on to our next CEO. So Sridhar, he's super into AI, super smart guy, and he's like, okay, this is where it's all going, because you can't have a good AI strategy unless you have a good data strategy. But if we're going to be the place where all this data is, you really don't want people extracting the data and running it, because one, it's, I saw a funny thing. I'm just interrupting myself.
No, you're good.
You know how like people with seismic data is so massive, and people say it really isn't big data until you can't back it up.
Yeah.
This is the thing. So, but when you have this huge amount of data, it's hard to extract it because it'll be slow. You got to extract it. You got to run somewhere else. And then maybe you're pushing the data back. So if you can run it in the same platform, then you're going to be a lot better off. It'll be faster. And so we now call ourselves the AI data cloud, which is taking on board that we're still this platform for your data. It's going to be secure. It's going to be governed. It's going to be one engine, not multiple engines, as we've seen with some other providers. But on top of that, we're going to natively be able to run AI. So we have, for instance, our own notebook, which you've probably seen in your account. You can, run Python. We have Anaconda channel with thousands of libraries that are there. You're not limited to those. You can upload your own Python libraries if you want. But that means you're responsible for the whole dependencies with all the other libraries, but you can absolutely do it. We bought Streamlit, which is a great Python library for applications, and now we can host that. So it doesn't mean you can't host your own Streamlit outside of Snowflake, but if you've got one, and we have a lot of quick starts where you can see with like 100 lines of code, you can have a really powerful app. You can share to anybody in your company. You don't have to worry about turning it on, where I'm going to host it. I'm going to stick it in an EC2 machine or something like that. Nope, you just have it. You can say share it to whoever you want. And just like the rest of Snowflake, when you go to run it, it's going to spin up. Now it may take us slightly longer. Maybe that one will take a few minutes, but not a few minutes, a few seconds to start up, but you'll see it. Hey, it's starting, and then boom, it's there. And then when it's done, it just goes back to sleep again.
It's wild.
So it is wild. For one, I love that by default, your stuff turns itself off because everyone who's ever touched the cloud has left something on accident and gotten a bill and been like, oh, I thought I turned that off. And it's like,
for no business value.
Right. It just sat there and ran for some money. 3 months for no reason. And then you finally check the bill and you're like, oh shit, Hope for me, fortunately, most of those have only been a few dollars at a time, but even then you're still annoyed by it. And it's just like, it should turn off if it's not doing anything. But as someone who's been working kind of on the language model space for the last year, I'm very curious, like Postgres has come out with PG Vector. I'm very curious, since you're talking about AI and that sort of thing, do you see Snowflake? Because the really weird thing for me when I first started getting into vector databases and stuff was like, oh, so I have to stand up a vector database, but then I still have to have a relational database to understand what the hell is happening in my vector database. And it's like, well, that's annoying. Like, it doesn't make sense in most situations because most people are going to want to understand the relationships of what's in there and even just metadata and stuff like that about the vectors that are in there. And so do you see Snowflake getting into that space at all, or do you see it being more on the kind of enablement side, like you're talking about, where you can leverage AI via Python, et cetera, building on top of existing data sets?
Yeah, so that is a very good question. So I'll answer it in a few ways. So one way is, so we have a bunch of quick starts. So we love people to get their hands on Snowflake, and one of the quick starts is a RAG quick start. And for RAG to work, so retrieval augmented generation, meaning we're going to take data out of some of your documents because the LLMs weren't trained with your documents, and we need to store it somewhere. Typically, that'll be a vector database. And we have the ability to run Pinecone in a container services. But for a lot of RAG processes, you just need that vector column. So a Snowflake table now has a special column type, which is vector. So in the RAG quick start we have, it will just use a regular Snowflake table. We're going to put all those vectors in that table. And how I kind of explain it to people is like, think of like if the LLM is the brain, it doesn't know about your data and all those things, but we need to add some neurons to improve the answer, because if that was trained 2 years ago, it needs to know stuff from today. It needs to know stuff from your data. So we're going to basically write those neurons into this table, and then usually you'll have some kind of front end. We have a couple options for that, but one is having Streamlit with a chat bot and being able to ask questions. And now you can choose which LLM you want. So we're hosting multiple LLMs. So we have our own, what we've trained, called Arctic, which is very good for like enterprise level stuff. It can generate SQL. It understands like metadata about databases, but it can't write like a Shakespeare sonnet or something like that. Like it's
important. It's niche. It's focused.
Yes, but it's very efficient and token wise. So we've got that, but we've got some big models like Mistral Large. We've got Mixtral. We've got some of the Google ones, Gemmas. We've got some Llamas like Llama 3s. And so we have other ones out there, and then we have some other models or access to other models. So we Nemo models from NVIDIA. As part of our partnership there, we bought a company and we have our model from that called Arctic Tilt. So it now will be in your accounts, called Document AI. So if you have a PDF and you need to extract content from unstructured, this could be in text or images, it will basically allow you to write the output of that to a table, but you just ask questions in natural language of the document and it'll come back with the answer. And then you can say, these are the questions I want out of these documents. And if later the format that they move around or whatever, it's a very good for a one shot or whatever they call it, zero shot model, where, you can just ask the question and you'll be shocked. Like it'll give you the right answer almost every time. If it doesn't, in the training process, we recommend, 20 to 50 documents. You go through and you say, yes, this is the right answer, or no, this is not the right answer. And then after that, then you can run your process again, and it'll improve even more. But so that's an example of text image layout transformer. That's our Arctic Tilt model. So that's one we own. But the other Arctic one it's open source. We also, I think it costs us around $3 million, but to show you the end-to-end process of training your own from scratch. And, so we documented it. We have a huge research team of these, and we put it up on Hugging Face and everything. So you don't have to have Snowflake to play with it. You can get it from Hugging Face and go play.
No, that's interesting. I've been talking about this for months, so I'm glad you bring it up. I still think people are sleeping very much so on language models for what you just described, which is extracting data from what appears to be a structured document known as a PDF, which is honestly just the worst document format that really exists, as someone who's been beating their head against them for the last 6 months. But using language models to extract data from your existing data sets into a new data set is like a cheat code. It really feels like these days. It's just because like alternatively, I would have had to manually do these things, right? Or it's like, or I can just write a loop that, that does this across all my files and then go back and fix the ones that look wrong.
Yeah, I highly recommend people go take a look at Document AI, because they will, if this is the kind of thing you need to do, it's just so easy. It doesn't mean you can't run Python and do things. And I'm talking to a customer right now that they download data from the Army Corps of Engineers, and that data is in a terrible format as well because it's giant PDFs, but they need to extract things from there. And so it's a combination of needing to extract specific small things and then maybe also the summaries. And so this may be a combination of a Document AI to pull out the small bits and something like a very simple PDF thing, extractor. So we have like PyPDF, and there's a bunch of, if you look at the Anaconda libraries, there's a ton of them to go pull out, something else that's needed. And maybe that's a RAG process where you ask questions of the data and get an answer. And, we had one of our SEs early on in this process took all of our documentation and shoved it into an LLM. And because sometimes the answer that a customer needs, it really came from 3 different pages. And one of the things was, so Sridhar came from a company called Neva, and what they were trying to solve a problem of, not only when I give you the answer when you search, but I need to give you provenance of how I got that answer. Sort of in this age of like, how do I trust this response? It links back to where it got it. And you're going to see some elements of that with LLMs, because it's like, okay, how did the LLM get from there to this kind of weird answer? Why did it hallucinate in this way? And so you'll see, like in a lot of our quick starts, it'll have, here's the answer, and then here's a link to the PDF or the resource that did that. So.
Yeah, that's one of the big things we're focused on, which is why I brought up metadata on those vectors. Is it's like, most people, especially engineers, want to know where the answer came from, right? And so especially when you have a RAG where it is only pulling the answers from the data set that you give it, it should be expected almost, in my mind, that it should return where it got the data from, right? It should cite the sources. And so that's it's a fascinating area, because there's so many different, you've got the existing incumbent Postgres kind of databases trying to get into the vector database game. Then you've got all these new vector databases that are only vector databases. And it's like, can you survive as just a vector database? Because most people need more than just a vector database. Yeah,
it's pros and cons. And like they'll say, well, I can get you speed and everything. But then you're right. But then, our whole thing is about unsiloing data.
Yeah.
And if you take nothing away from like the problem we're trying to solve, is we're trying to break down all the data silos. And it's really hard. That's an area where, like Hadoop would have said, oh, you need a different data, thing to store this image or this PDF. And we're saying, well, actually, you could have it all in one platform. Yeah. And so from day one, I'll just throw out, so one of the other areas where that really helped us as we grew was we could store structured and semi-structured data, so JSON files, Parquet, in the same manner. And so, and there was zero performance degradation. And so that was a big breakthrough, because some of our early customers were like video game customers that were like, it's spitting out huge amount of JSON and everything. They're like, well, we can't query this, and our Hadoop is slow. And we're like, no, we just load it into Snowflake, query the JSON in place, and then you can address every tag in that. So think of like a regular table that has like 10 columns. You think about like, how could you write that in a way that I can retrieve those columns? And then as JSON, maybe it's got 100 different tags, but all we do when we load it is we take every tag and we sort of columnarize it.
Okay.
So we sort of present as a column or database. And so we were able to process, thousands, millions of JSON and Parquets and everything at the same speed. And so a lot of our early customers were moving Hadoops or like solving problems where, like in the ad tech space, where you're trying to just massive amounts of data and just being able to just query it super fast. And it just worked just like you would expect. We extended SQL to where you'd have like the name of the column, double colon, and the tag name. But otherwise, performance is good. And so you could put a view on a table that has JSON and then point it at Power BI or Tableau or ThoughtSpot or Sigma, and it would just work. And again, so that was another area where people migrated to us because we just were very, very good at that.
Yeah, I mean, and I think that's probably even another part of what made the whole ELT paradigm, more doable. Because like I just put it in whatever format I have, I still have the granularity, but I can get it. And it doesn't just have to be rectangular data. It can be that more unstructured data.
Yeah.
I mean, I think, well, I've tried and failed, but I mean, messing around with XML was a little more crazy. The lateral flatten and everything was a little hairy, but
yeah, I mean, technically we do support doing that, but yes, it's talking about terrible formats. XML is a terrible format.
Yes.
JSON is much better. So I would always try to encourage people to get away from it. But back to your other point of like, how can you survive if you have to have a different silo of the data? I think it is going to be hard for some kind of companies, and they're trying to find, their niche. All of them are trying to find their niche.
No, I think there's this weird, like, especially in tech, early on, it's just like the tinkerers and just, us nerds playing with new shit because it's new, right? Like only because it's new. And then, you go through the whole crossing the chasm cycle, but there's this weird thing about a lot of new tech and the fact that it's like, it feels so easy to the user that they don't realize that like, hey, Pinecone is a good, vector database if I just am trying to spin up a very specific RAG model for a very specific thing, probably not large scale production, enterprise grade stuff. But if I'm just trying to do that internally, not a problem. But then you start throwing more stuff into it and there's more context overlap. And then it's like, oh, well, now I need all this additional data that I can't even put into Pinecone. So now I have to set up an actual database and then link them, even though they don't want to be linked. It's just this messy, I see it. And it's just like, oh, okay, now I see why. Because it's like, they make it easy to quickly go look like you've achieved something, which, the value of that is whatever. But then it's like that jump from that to a production scale version is so big, but they make it look like it's going to be really easy because that first little thing, that iteration that you did or their example made it seem like, oh shit, well, I can talk to all my documents now. That's awesome. I can do this with all of my documents. It's like it's a very different scenario once you start getting into production worthy type software and stuff like that. So I'm very curious to see how that works, but I feel it's the same way with the language models as a whole, right? As it's like GPT has put out all these products, or OpenAI, around building your own GPTs and your RAGs and your own agents and stuff. And it's like, again, at small scale, those I think work fine, but they're not, it's very hard for someone to go out and productionize something like that into, the entire community to make it worthy of people paying for it and things like that. So it's this weird like dichotomy where it's like the facade is, oh, it's easy and everyone's doing this and everyone should be doing this. And then the actual thing from an enterprise corporate perspective is like, wait a minute.
How much is this going to cost me? How can I monitor it?
That's why like RAG, in my opinion, one of the reasons why RAG is and I think still will be very popular is because, hey, instead of training a custom model, that's just an endless, never-ending process and expense, essentially, because you always have new data coming in, so you're always having to update it. Or we could just do a RAG where we just build it one time. We don't have to have all this custom training and spend millions of dollars doing it and have the compute resources even. Like that's going to be a harder and harder thing, I think, moving forward. So but
I think that comes back to what he was saying earlier. You guys have the compute resources and they're just sitting there waiting for you to use them, but you're not paying for them until you access them.
Exactly. Yeah, and so fine tuning is another area where that potentially fits in there. We now have fine tuning in one command, one SQL statement. You can fine tune one of the models to kind of do more what you want. And there's this also interesting thing where it's maybe for let's say you're trying to classify something using a model. You might use like something like a mixture large to get the output. And you're then train a cheaper model to go say, hey, this is what I want to see. So you're doing a fine tuning and then using the cheaper model. So with a lot less tokens to do your day-to-day thing. So there may be a process, and the benefit of having some of these other models there is you can try them out and see which one has the best result, but you might use the output of one to save you money downstream. So it's real interesting.
Yeah.
Nice.
Yeah. There's it's not weird. It makes sense when you think about it, but it's fascinating on the language model side. It's either really big, getting bigger all the time and more, or it's complete opposite. It can run on a Raspberry Pi. Everybody's going one of two routes. And I was talking to our intern about this yesterday, and I was like, I genuinely think like the way things are going, you can kind of see how it's like, oh, well, OpenAI can't keep running all of this stuff on their own stuff forever. Like that doesn't work. And then you think about like, oh, Apple's got, I don't know how many millions, hundreds of millions of devices worldwide. And then I was like, well, shit, if Apple just rolled out an iOS update with built-in on-prem language model, they now have the biggest distributed computing network in the world, just like overnight, basically. And it's like, oh, okay. So the idea here is distribute the compute to the user so that they don't have to pay for the cloud compute resources to run and maintain it. That actually makes a lot of sense as far as like combine that with all the edge compute stuff. And it's like, okay, I can kind of see that now. But it was really weird for me initially when they first started rolling out these smaller models, like, why are they going smaller? But then you're like, oh yeah, so it can run on your device and not theirs.
Yeah, Arctic Tilt is considered a smaller model, but it's like I said, it's very effective. But it knows it can pull apart a document, like it can get the handwriting off of a document. And I was like, how did you do that? But it's just like the way they trained the team that did it. Yeah. That company was called Applica. We bought it.
Okay,
and now it's part of the GUI. So that's kind of our model. Is we buy companies, we roll in the tech, and we stick it as part of the GUI and just try to make it available. And we're a consumption model, so you pay for it if you use it. If you don't use it, you don't have to pay for it. Another example of that, we bought a company called Samuha. They do clean rooms. So if you're into clean rooms, it's all part of the GUI. You can just turn it on, and then we integrated other partners into that. So if you need to do like identity resolution of who this person is, then you can choose from a number of options, and maybe you're already using one of them and just slot it in, and then you can compare. And you see this sometimes with mergers. It's like I can't see all the data. The government's going to say, okay, maybe you have a small group of people that can see things, but most of the people can't. So you can agree on like where we're going to allow you to query data and see an aggregated result, but you can't see the lower level PII. So so Disney and NBC Universal, they're building their platforms on Snowflake because then now they can like share with other people that are going to buy content or whatever. Like I need to know how to target somebody that went to a Disney park and watched Moana or something. And then they can say, well, I'm not going to tell you who they are, but here's some slots where you can target those people. So yeah, there's a lot of really interesting things happening there.
Nice. So I think one or two more things I want to get into with Snowflake before we, because we're already getting even closer now. It's crazy.
So this is 3 hours, right?
Yeah, exactly.
We have had those requests.
So I mean, again, I think a lot of people think of Snowflake and they think of SQL, obviously, right? Because like a data warehouse, that's what it originally was. But can we talk about like Snowpark? And then also one thing I'm excited about is the new like Snowpark Pandas. I think where y'all integrated like Modin and stuff like that. So what those are, and then maybe if we have time to get into some of the data ingestion, like the Snowpipe and the streaming and all that. But
okay, sure. So yeah, so originally we have an engine, and how I think of it is like there's SQL is nothing runs it natively, right? Like at the end, it's getting down into ones and zeros or whatever. So we have an engine that most people think about it just could be SQL, and so it compiles down into the bytecode that goes and runs. So that's SQL, but there doesn't have to be SQL, and so we've made versions of that for Python, Java, and Scala. But it's still the same engine. So it looks to you like, oh, Snowflake's running a bunch of different languages. It is, but it was always compiling down into something else and then running. Okay. So that's how this works. So we have SQL, we have Python. Those are, I think, probably the two most popular, but we also run Java and Scala. And here's an interesting thing about how we've done this. And people wondered, well, why did Java come out first? And it's because we're hyper aware of security and things like that. And so one of the things that Java had is it's naturally sandboxed. Yeah. So you could say, hey, you're not allowed to go do these things. And Python does not have that. And some enterprises get very worried because in a world where you can pip install anything from some dude who wrote it on the internet, it just works, right? If you go on your laptop and you say pip install this, homebrew that, it's going to pull it down and it's going to run. And we had a very famous case from a few months ago where somebody modified an open source library and almost, probably could compromise every, Linux machine in the world. And luckily at the very last second, same kind of thing of the book you were talking about earlier, where, somebody was like, hey, why is this a little slower? And then figured out, oh my gosh, there's this thing that happened.
Oh man.
So we spent, and this took us a long time, but our Python runs in a sandbox. So you can't mine Bitcoin or, exfiltrate data, in those ways. But otherwise it works with Anaconda, and you can have your own libraries and do all that. So it's a more enterprise friendly way of running Python. We try to keep as much of the syntax as you can, so you can move very easily. Our syntax is sort of based on PySpark. So if you came from the PySpark world, you should be very comfortable doing that. And now you get into what you just asked, which is, okay, how do I get performance on all these things? How do I take advantage of multi-compute? So, by default, we're an MPP database, meaning, we can, if you have one extra small machine, that's one thing, although maybe there's 8 cores, but we can have up to 6XL, which is 512 machines. But certain things will parallelize, certain things will not. And so we purchased Modin, and then we've integrated that in. And so now it just makes it so where certain things can run a lot faster and parallelize better.
Yeah, and I guess for people who don't know about Modin, it's just a Python. I mean, not just, there's a lot going on under the hood, but at its core, and I think I first used it at RDS when we worked together previously, but it was like, you just take your Pandas code, and with like one line of code, you just install Modin or whatever, and just your Pandas works, but it goes way faster. It uses all the cores and can parallelize. And
yes.
But now y'all have that in, like you can run it like within a Python notebook or the Snowpark Pandas, and it will just automatically parallelize your Pandas code or.
Yes. Yeah. And so that's what we're constantly taking feedback. So we would love to hear how people are using it, if things they like, things they don't like, but that's the idea is your code should run the way you expect it to. It should run fast. It should just work. One of the things that is coming in now, it's very hard as SE to keep up on everything. Sure. And we're they're breaking us internally into colleges, and I'm in the data science college, but you kind of have to know about everything, and we're getting to the point where it's hard to know about everything. But one of the things that I just took training on is observability of all these things. So as you have store procedures or these things, how do I know, like, am I running out of memory or this or that? So we have a concept of event tables, and there's one in your account. There will be a default one that will just be there, but now you can create it. But what we're doing is we're making it much easier for you to see, and we're using an open source observability format. Okay. So that if you have like a Grafana or Datadog or something like that can read those formats, it'll automatically work with those tables. But we also have it as part of the GUI. So you can see, hey, I've got here's my process, but it spun out these 8 different processes, and how long did each process take, and where can I go debug these things? And so we're making that significantly easier within the platform. And so, happy to get any kind of feedback on how people are liking that, or there are more things that they want, but we're making that much easier. You ask another part of the question, which I don't remember now.
Well, I think the next part was just maybe if we want to get into like some of the data ingestion side. Just maybe high level, what is Snowpipe? And then I know recently the Snowpipe streaming, I think people are getting a lot of realizing a lot of even cost benefits from that. And
yes. And I think that's how you found me originally. When I looked in my message thing on LinkedIn, you had some questions about it. So basically, what Snowpipe is serverless ingestion. So what we mean by serverless is there's a concept of a warehouse in Snowflake. And this is like the t-shirts you were talking about. So extra small, whatever. And so the price to beat is the warehouse price. So let's say you're running at enterprise level and it's $3 an hour. So if you're continually sending data to Snowflake, if your serverless process was more than $3 an hour, you wouldn't use it. You would just switch to a warehouse. But the idea is if the warehouse was $3 an hour, what Snowpipe does is it charges you per the size of file and the number of files. So imagine a case where that is now $1.50 or $1. That's significantly cheaper to move to serverless. You should switch over to that. We also have connections to things like Kafka, and Kafka will also have different parameters. So Kafka, I think, is you can say number of rows, time, or number of bytes, something like that. And so you can tell it to, hey, build files of a certain size that make it so that Snowpipe is, very cost efficient. But when you start getting into telemetry, real-time telemetry, the number of files, there'd be so many of them that your Snowpipe costs would be too high. And so you'd say, well, you could go back to a warehouse, but customers didn't necessarily want to do that. They still want a serverless way. And so that's where Snowpipe Streaming comes in. So it's basically an API. And because of our size and scale, all of our partners, will also support these kind of things. This is why, for instance, on the BI front, if somebody says, oh, I have Power BI or Tableau or Sigma or whatever, it just works because there's so many customers on the platform that they want to make sure that their things work well with us. Same on the ingestion. So we would say, yes, you need to stream the data in. You can call this API, and then behind the scenes, we're storing it in a different way, but then we're writing out the tables that you would normally expect, and you just don't have to worry about it. You just call the API, writes it, and that could be, everything's different. You have to look at your profile, but like it could be 10% of the cost of Snowpipe.
Yeah.
So it's suddenly we're seeing this huge shift, and you can move gigabytes per second or something. And I don't know, like I think I could have the number wrong, but something like, I think we load like 70 terabytes of like data security logs a day.
Wow.
Like it's insane. But like, so because if you think of it, if millions of machines, you're looking at when do they start? When do they stop? What happened? So you're writing a bunch of logs, and we're just absorbing this huge amount, which is why a lot of companies do use this for their cybersecurity data lakes.
Okay.
Because again, it's like, do you want to have regular data with your cybersecurity data? It sounds like traditionally that's been two different things. Like maybe it's a Splunk, but then there's areas where the things come together. It's like, hey, maybe that is normal, but if I have to know that this employee, why does this employee who left our company 2 months ago clicking a link that, like maybe that's going to, that should be an event I look at depending on whether it was somebody who hadn't left kind of thing. So there's a good reason, I think, to have your cybersecurity data next to your structured data, because there's times where you need to kind of have a look across. So, hopefully that answers on streaming. So it's a way to very efficiently move in time series data. And there's so many things happening there. I made myself some links. So MQTT, I went to the Intellect conference here in Houston. It's a lot of like IoT and how do I move data over and stuff. And so there's like, there's a guy, Arlen Nipper, he was part of the MQTT standard, and they have things like Ignition and Cirrus Link and standards like Sparkplug, where you can just like turn on, a remote site, and it sees all the tags, and it builds up basically what your plant looks like, just as part of this standard, because the tag has the metadata, how it relates to other things. And so you can suddenly see it. And if later that you swap out the sensor, it sort of re-registers, and then it says, all right, now this thing has gone from version 1 to version 2, and maybe it has these other properties that it didn't have before. So it's kind of cool to see all that. And so, we were there as part of that.
Very cool.
The security logs made me think of the book Cuckoo's Egg, because that was what was it? He would go in and he would find like old emails that hadn't been logged in, and then he would log it. He would hack their password, and then he would go into that account and then use that account, which is now a permissioned normal account, to create his hacker account that was outside of the network. And it's like, had someone just been paying attention to the fact that these people who left the company 6 months ago are logging in and creating users, that never would have happened.
So I think we're getting close. Like one thing I want to do before the speed round, because we didn't really get to talk a lot about use cases, but I would say, do you have like a kind of a favorite use case that you've worked on in like energy or oil and gas, like where like, or kind of a unique one where like, I never thought about using it, Snowflake in that way?
Oh, there's so many. I'm just trying to think of one of my customers worked on. I mean, I love the takeouts. To me, it's like where somebody had used Hadoop and they struggled with Hadoop.
Yeah.
In our region, one of the first, and this is where it gets into like, oil and gas is a tech world, right? I mean, you're drilling deeper. You have to have a lot of tech to be able to do stuff, and directional wells and all these kind of things. And so like a Devon and a Chesapeake, or in our region, the two first Snowflake users, I think they joined in 2018 or something. Referenceable customers, they've got case studies up there. But like Chesapeake, they push us in certain ways as well. So to give you an idea, we're their historian. And I'm not saying that we're a historian. I wrote a blog, and maybe this is how you found me, like a couple years ago, like, is somebody had asked the question, is Snowflake the best time series database in the world? And we're not a time series database, but we're really good at time series use cases. And that's what Chesapeake found. It's like, as they move over these massive Hadoops, they're like, wait, I can query this at scale and I can have all these tags and it just works. They're like, hey, we're not getting the benefit of our historian. Snowflake's our historian. So we're like, whoa, wait a minute.
That's not what we're.
Yeah. But, and so they pushed us and so you've seen some new features come in, like as of joins. So, things you would see like in a time series database that we now support because customers are using us in these ways that in some cases stretch us. And then we're saying, that's something we should be doing. And we put it into engineering and then, we'll come out and they'll test it and give us feedback and things like that. So I think those are some of my favorites where, we've solved a problem they had, they struggle with Hadoop or something like that. And then suddenly everything just works and people are happy. I love to do hands-on labs. We call them 0 to Snowflakes. We did one for a big energy company and they had this massive Hadoop cluster and they were moving away from it. And we did the 0 to Snowflake, but then they also have some of their own data there. And this is where kind of the early days of our Iceberg support. And so this is some data they're like, we're never moving into Snowflake. And people ask the question, well, why would Snowflake support Iceberg? It's because there's some workloads that customers say, you know what, I've got it over there. It's too much. I don't want to move it into Snowflake, but I struggle with the compute. And we want customers to be able to query that data and have it perform well. Yep. And so we ran this query on their data in this session. And it's just there when you're in front of a crowd of people and it's taken like 3 minutes and I'm up there going, I don't know. I need to look at this. And part of it is like the sizing of the files and everything is like, because they're in control. In their case, it was unmanaged Iceberg. So they have to control the size of the files. And it came back after 3 minutes and there was kind of a reaction. And I'm like, well, we can look at the tuning. And they're like, you don't get it. Said this query would have run 6 hours on our cluster and most of the time it dies. Yeah. And you just ran it in 3 minutes. This is like amazing. So awesome. Those are the kind of reactions that I like. So I think some of those where there's just a big takeout where the customer's happy and that just is a good feeling when they say, hey, I've got 99 problems in IT, but Snowflake isn't one of them.
Yeah, absolutely.
I mean, just being able to take customer feedback like you were talking about the historian. I know almost every oil and gas customer that I have personal relationships with hate their historian. Yeah. And it's like, that is the incumbent historian that has been there. And
or you have to move it off of your historian into something.
Exactly. And it's like, so now that's exactly, it gives me the exact same vibes that the vector database and database stuff gives me. It's like, this doesn't make sense that we have to do it this way. And at some point, someone's going to come along and figure this out so that you don't have to do it that way. And they're going to win. And so it's just
SCADA systems, like that was always one where I thought like, SCADA systems will never move because like if the plant blows up, if we can't get the data, I don't want to be that system. But there's some flavors of it to where it's like, okay, but most stuff could run out. Yes, you do need shutdown and safety and things, but we're starting to see that as there's SCADA companies moving to the cloud. So people want to have access to their own data. They don't want to say no, everything should move here. It's like this is a conversation that I had with one of those data providers. They're like, customers were asking them for shares, and we collected a list. I want to say like 100 customers were saying they want a live share. They're like, but don't they know that there's just a very easy API to call and they could just download the data? And it's like, but it's not as easy as just being able to query the table. Yeah, and so eventually they get,
most APIs suck.
I was gonna say, Bobby and I
the
have
timeliness and you have to babysit. That's another thing you have to babysit.
No, it's then they change, they update their auth from 0 to 1 or 2, and then you have to rewrite the whole thing. That's like Bobby turned me on to Fivetran. I know they use Fivetran for that very
Fivetran then keeps the pain of that because they keep up with that.
They manage the APIs. Yeah. It's like, hey, I don't have to rewrite it, and it just works. Yeah. That's what most people want. But then if you don't
have to pay for Fivetran,
well, but even then, Fivetran is a fraction of what it would cost me to have a data engineer just.
Well, no, it is. But I mean, one thing we didn't really get into, and again, we're running up on time, so I want to go too deep. But I mean, I know that you guys have some native connectors now too. Like I think you can connect to MySQL and Postgres. I think they're working on SQL Server is what my SE told me, but where you can just point Snowflake at your SQL servers and just ingest directly.
It just
or MySQL
will never cease to blow my mind that so many tech companies don't understand that you're only as valuable as how your clients are wanting to use you. And if you can't integrate your product with their workflows, they will find a different way, or someone else will build it integrated. Like there's only two options there. And it's like, yeah, you might be the incumbent for 10, 15 years, but at some point, someone is going to get frustrated enough as an end user that they're going to try and figure out how to solve it themselves. And
for sure. Yeah. Yeah. So yes, we do have connectors. There's some that we own, some that other people own. There's native connectors. ServiceNow, Google Analytics 4, there's a connector. Oh, nice. You've probably seen it up there. So yes, in public preview, MySQL and Postgres. So it's the first thing that really steps us out of the cloud, because it's a Docker image that runs on your site that can read it can read the logs of the database and then push it to us. And this is just customers pushing us to like, hey, we need to do this, and you guys should know this better. And so again, if I'd say, hey, get Fivetran, they do a really good job of it. Click has a tune, or used to be a Tunity Replicate, now it's Click Replicate. There's things that do it really well, but they're like, gosh, you could just do this one thing, and there's some standards. So we have done some of that. You probably see some more coming over time, but for the most part, it's just we're working on the platform, and we've got a lot of great partners, and solve the problem in the cheapest way you can.
Absolutely, like perfect example. I am now going to go look at that connector because I don't have to pay Fivetran to replicate it over to Snowflake instead of.
Which is ironic because have been using BigQuery and.
But
Google Analytics.
I also would like,
well, that was the thing. So BigQuery, I think we want to work better with Google. So I would say, if you look at it, AWS is where we started. That's where the most of Snowflake runs. Azure is a huge, fastest growing. I don't know the exact percentages. We've talked about it on our earnings call, but let's say it's 25%. So it's like 74%, 25%, and like 1% Google. And that's because Google, well, like some cases, yes, we have an engineering relationship, but they're very much like, hey, we're going to do it. And, and so that was a case where customers are like, I don't want to have a BigQuery, but you're making me have a BigQuery for Google Analytics 4. So this connector essentially runs all that. So you don't have to have your own BigQuery, but we would have much rather had a live share or something like that.
Yeah.
But
Google,
we don't have an option for it.
GCP is such a weird company. Just like hard stop. I feel like they do some really interesting, cool stuff, and then they do some really dumb stuff that you're like, how the hell did this happen? When Llama 2 came out, for example, they came out with Vertex Studio and all this stuff. I was like, oh, hell yeah, I'm going to go spin up a Llama 2 instance. I couldn't, because
have you seen Gemma?
Yeah. Well, I haven't even tried. I just quit trying to spin up anything on GCP because I found through Google support forums that GCP doesn't have any of the resources that will run these models. Yeah, like, then why did they roll the damn thing out? Like, it doesn't make any sense. You're just making yourself look bad. Like, anyway, GCP rant over. I still use GCP all the time. But
you want to do
do
one or two? Yeah. We just kind of do like a little lightning round kind of thing, but nothing too crazy. But
since I've been talking about books, I'll go. What's your favorite either tech or just book? A book.
A book. I just got the new Elon Musk thing. I haven't read it yet, but maybe I'll read it on my trip here. I like all the old books, like because I'm a data warehousing guy, like a Data Warehouse Toolkit, the Ron Kimball books, and Inman, Corporate Information Factory, those kind of things. That's been a while. That's many years. That dates me, but you can see I got some gray hair. That's the first thing that pop into mind if it's a workbook. Yeah.
I'm glad I'm not the only one listening to books like that. My wife, we were driving over the 4th of July, and I started listening to that Cuckoo's Egg book, and it was like 11:30. We ended up pulling up to the house at like 12:30 at night, and she had fallen asleep, and she woke up and she was listening to the book with me. She's like, "You listen to this to stay awake?" I'm like,
no, that's a classic one. Another one is it Hackers? I can't. There's in that vein or whatever. But that was a great book.
I'm glad I'm not the only one nerding out to fun stuff.
And I guess I'll finish up. What's your favorite open source library?
We come with the hard hitting questions here.
Yeah, you can edit out my pause of whatever. I mean, just recently, because I was looking at it, it was Pi PDF because I needed that for the quick start. Or there's another one. Is it Tesseract? Or I forget.
Tesseract OCR.
Yeah, because somebody said, "Oh, I have this PDF," but then when you looked at it, it looked like text, but it was really images.
It was an image
And
tag,
so you have to like use Tesseract to pull it out. So those are all part of our Anaconda distribution. So you don't have to do anything crazy. You just have to go into your thing and say, add in this one, and then you can start using it.
Nice.
So I'd probably be those. Yeah.
Well, sweet. Well,
thank you so much.
Thanks for taking time out for us ahead of your awesome trip. So
no worries. I live nearby, so you know, if you ever, you know, we can, if we didn't get to everything you wanted to, happy to come back and answer questions.
Perfect. Sounds good.
Thanks for joining us. Shout out to Zach and the guys at Fortran for the
forecast.
Forecast. 4chan is a very different organization.
Fortran.
I thought you mixed 5tran and
4chan and 5tran. I did. That's exactly what.
Fortran was a very old language.
For the swag, and we'll see you guys next time. Appreciate it.
Thanks, y'all.